Day to you, this is Anagalactic. Pardon the garb, but it got suddenly chilly here. Bošković did not know anything about the strong nuclear force. One of the binding forces inside the atom. So the strong nuclear force is not something that Bošković was really thinking about 2.5 centuries ago when he drew this exact curve. Well, a lot of top-notch physicists are finding that to be just suddenly remarkable. This guy 2.5 centuries ago was drawing the strong nuclear force curve when the particle hadn't even been discovered. And it's like, wow. I mean, I hope you're impressed. Oh, it's coming back up in Italy. You know, Italy, they're going kind of nuts over Bošković. Because the Italians keep up with science. I mean, certainly better than Americans do. Oh my God. You know, I should move to Italy. I would if I could. Well, and I spoke Italian. You don't want to move to a country where you don't speak their language. I did so anyway because I think all Americans should travel. Okay, because we're in the new world. Hello, we're on the world's biggest island. There are like 6 islands on Earth. My interests in science are quite eclectic. All right. So you'll notice there's a green line, and I really botched it, I think, in explaining what that green line is doing here. Well, first of all, you have to know why this guy drew this at all. This is from an article on proton-proton interaction. The strong force, what they wanted in the strong force is, for God's sake, get the energy out of it to make another bomb. I mean, that's not talking out of school, kids. That's why there's hadron colliders, is to get a super-duper bomb, which you would then have to dumb down. By the way, the Earth was almost destroyed in 1960 by the Doomsday device. The Russians invented a Doomsday device. And if they had set it off at what they expected, the megatonnage, this is over in Nova Zemlya. I was like 6 years old, so I was there for this. When the world could have been devastated. It was... I think you know about atomic bombs. I have... This is like a super atomic bomb. That's what thermo means in thermonuclear. I never really understood why that prefix was chosen, because all it means is like heat. Well, there's a reason for it. Of course, you can look it up in physics. But I mean, the world's biggest explosion, there's a reason I wear this hat. I know it's a government agency. I don't care. I still love them. They went into outer space, okay? So you write your own book. I made these presentations. And we go. Look at that. Well, I told you I lost it. Well, you don't want to know where I found it, but... So you see, the green line is electromagnetic force. Repulsion and attraction. Oh, yeah, that's what I really want to talk about. But let's approach this logically and carefully, because this is the deepest MFing thing. I hope you share my excitement eventually, but I'm telling you what, there's a reason I'm acting pixelated. I get frickin' either visionary or erotic or just worshipful, just in awe, just in a state of suspended bliss. I could just stare at this thing. Well, I have. In many forms. Well, I mean, not many forms. It's always the same. So I'm showing you something that actually is from the universe. So this, you know, in a certain religious context, you could say God, you know. I don't know how you feel about that. I just thought I'd throw it in. Hey, we're human, you know. Don't be afraid. I'm not going to go there. Don't worry. You should fear that. I used to be a preacher. Okay. Electromagnetic force. What's that doing here? Ruger was not talking about electromagnetism. It hadn't been discovered. It wasn't discovered until the 19th century. Well, he lived in the previous century. He's going back. So what, in other words, what the hell is this green line doing on top of the Bošković Force Curve, which is in magenta? I am not colorblind, but, there's a lot of colors. That could be indigo for all I know, but the top one is obviously green. And why is it there? Well, I love that. Let me just tell you why it's there. You can think of it as, I know, but I have to put it this way. You can think of it as the force curve relation between two electrons. So let me explain that, because you're seeing the unified field solution. Okay, so I'm just warning you, this is so deep, you may not come back. If you like someone just steps into quicksand and everyone's standing on the shore while he's, hey, because he can't get out. The more you thrash, the deeper you sink. You can't swim because you're too far under. You're going under unless they help you. Think about that. You don't want to step into quicksand unless you really trust your friends, because they could just, good. And they stand there, hey. Well, that's what it's like waiting for me to get to the point. The audience is just thinking, hey, you're still not getting to the point, which is always a pun in geometry. All right. So the electromagnetic force line in jade is showing is no such thing. That's ridiculous. Just scratch that out. I should have a red highlighter. All these pros have ways. I can just go scratch with like scarlet red ink, so you can still kind of see what I'm scratching out. Yeah. And write in electron, temporospatial relationship. That's what that is, I just told you. So why is it sloping up? Why is it doubly asymptotic? Okay, let's have a quiz here. What's an asymptote? Well, you see at least 4. There are 4 asymptotes here. So that should tell you what an asymptote is. You should be pretty close to getting the right answer, right? This is a quiz. I'm your professor now. Oh, yeah. You see, I love my hat. Okay, I gotta cut this off, but I do want to finally tell you what this means. It's doubly asymptotic, and actually, so we'll call it green right asymptote, where it says nucleon separation. Scratch that out. Well, no, that is correct, right? But it's not as precise as it might be. Don't forget, the guy who drew this, or the machine under the control of a group of humans that drew this, was looking to explain something about a proton-proton interaction. Gee, I wonder why anyone might be interested in that. Isn't that what they do at CERN? Where they're building a super ring that's actually going to go under Lake Geneva. It's just going to dwarf the collider that they've built. This big underground ring. Well, those are the people, essentially, that drew the magenta line. Which you're going to grow to love as soon as I tell you what it means. Oh my God, it's so exciting, I can't get the words out. I'm like, oh God, I want to go into identity crisis here, but okay. So the emerald line. I did have a look. Okay, yeah. We saw a video of a man die laughing because he took a hit of weed. Here's what can happen, and the guy laughs himself to death because his eyes were like painted, you know. He's just doing what I'm doing now, which warned us all, don't go the way of the hemp. So the emerald, the emerald electromagnetic force line describing the force relation between two electrons clearly indicates that they don't like each other. Because look, repulsion. Yeah, I'm gonna drag it over here. I'm gonna try this again. Repulsion! So the electrons just don't get along. So that's what that emerald line means, sloping up to temporal infinity. That's the disappearance of time itself into infinity. So that's what the upward curving part of the emerald line means. It's infinity of force. Repulsion. That's force, parentheses, repulsive force. Don't forget, the vertical line is indicating force, not trajectory. I like to repeat that because it's very important to realize that the particles are never on those curved lines. That's actually the meaning of, that's the deepest meaning, is the two curved lines never touch the median line in either dimension. Let me say that again because this solves the quantum paradox and extends the definition of spacetime so that they match. That's called the unified field solution. You're hearing it, so this is a worthy addendum to the previous. I never really got to that point, did I? But isn't that nice to know now? And I think I should just... No, I haven't really explained it yet. Okay. So the green line doesn't even belong here. Ruger did not draw it. It has nothing to do with what we're doing. But isn't that nice to... Because it interprets in an easily visualizable form that if that fucker is sloping up, they are repelling. That's repelling. So going down... sloping down. It says strong nuclear force, but that's actually not what we want it to mean. It just so happens that it means that as well. Okay, I hope that's not too confusing. In other words, two secrets of the universe, in addition to what you just saw so far, and we haven't gotten to the main point yet. It's the asymptotic line of the unit fractions towards zero. It can't reach zero if they're generated geometrically. You begin at 1/2, you're halfway to the target. You're the arrow, consider yourself a photon, and you're halfway to Earth from the star. That's 1/2. And now you go halfway again. That's 1/4. You will never reach the center if the center is 0. Correct? That is called ZENO's paradox. You're looking at the visual representation of ZENO's paradox in the asymptote of force in this graph. Although when it goes off to the right, it's not measuring force, it's measuring separation. It says nucleon separation. All we need to do is replace that word with the general term. It's like going from special to general. Nucleon is special separation of nucleons. We want the general separation of any two particles, so we can get the electron-proton relation, which the magenta line describes perfectly. So we're describing the inner orbit of a hydrogen electron orbiting a hydrogen proton. This is the force line that describes that. And there are two infinities that are perpendicular, but not in linear space. but you can see that they're perpendicular. That's what this graph shows. What is perpendicular? Going off to the right is linear spatial separation. That's the generalized term for that arrow pointing to that infinity that is an infinity. There are two infinities now. Thank Albert Einstein for that. This graph shows both of them in relation at the quantum curve limit, where our measurability remains on the horizontal line because it's quantized for linear spatial separation, but the curve leaves the line. It leaves the realm of measurability. And that's the dip in the curve. That range where it's dipping is what our linear numbers cannot measure, no matter what we do. And so our number system is broken with respect to reality. You're looking at the break. It's smooth. That is called the continuity. And that's why Ruger drew this curve. He drew the curve of continuity. It's inside the quantum. So he drew the quantum. It's the intersection of two infinities which we now need to identify. One of them we have already identified, linear spatial separation. Each word is critical. What about the vertical now? What is that? Well, you can see that it says repulsion and attraction. These are measures of spherical force. Spherical force. That is redundant if force is defined axiomatically correctly, which it is currently not, because force is interpreted as linear collision force. Linear collision force. Linear collision force. Linear. Not spherical. Linear. That's extremely important that you focus on that fact now in order to understand the next statement. The vertical infinity is Einsteinian time. This is the intersection of space and time. Disregard the emerald line. Just look at the magenta line and understand what's happening. There are two ways to visualize what's happening. The second way is the best because it's static. And it shows the permanent force relationship being depicted. That's the ultimate meaning of this. But there is a step that you and I can take which will give us a free pass to see exactly what that means. And it is done in this way. We do a Gedanken experiment that's directly implied in the diagram itself by imagining an electron that is now on that horizontal line about where my finger is, and it's moving toward the proton, which is right there at the cross, which otherwise would be zero, and in fact has to be zero. You know why that, where the vertical line meets the horizontal line on the left, do you know why the cross has to be zero? It's because those are lines, and every line has a zero. But curved space has no zero. And that's also what you're seeing here. And I've proved that. And that's what we'll get into later. But for now, to sum this up, so you know what this means. We're going to follow the electron as it approaches the proton. The proton is at the crosshair. the proton is considered to be, in this diagram, centered on 0. It has a radius, and this is part of the quantum paradox, that it has a radius, but it occupies the center. So there's something inside of it. There's something inside the proton, there has to be. But it also has to have a radius. It turns out that that's the quantum paradox also. We'll cover this in much greater detail. I'm just giving you the meaning of this graph. It has extraordinary meaning. And we're only scratching the surface now. But the way to get the free pass into this pavilion of wonders for you and I as laymen, we can now follow the path of the electron as it's on a collision course with the proton. This phenomenon has occupied the greatest minds in history for 2,000 years and more. The collision between two particles. That is what Roger was describing with this curve. The collision of two general particles. So our general particle is an electron. He didn't know that, and yet he drew the curve perfectly anyway. So the electron is heading toward the proton. The proton is at the crosshairs, whereas the electron, it began over here and is now accelerating. How do we know it's accelerating? How do we know it's going toward the proton at all? We know it's going toward the proton on a straight line. That can be proved. And the reason we know that the electron, no matter where it is, to all infinity, almost all, to almost all infinity, no matter how far away that electron is from the proton in an empty universe, it will be moving toward the proton. No matter how small the fraction of motion, it will be being drawn toward the proton. When it gets to within the 10 femtometer range, which is about the diameter, or not the diameter, but, well, actually it is the diameter of a sphere. Well, actually the radius. The distance that that electron is from the proton is a proportion, right? You could say it's a direct proportion, but it's definitely a proportion because it's changing. The distance is changing. It's going from 1/2 to 1/4 to 1/8. What happens when it crosses the ZENO finish line? It collides with the proton. If it actually did that, electrodynamics predicts that they would cancel out of the universe. But we already know that that can never happen. That is the most basic principle of physics. You don't cancel anything. There's no such thing as cancellation. So, what happens as the electron accelerates toward the target? This curve that dips and then goes up shows what happens at collision. This is the collision point. It is the collision point. And I'm emphasizing the word point. You may experience a jolt here when you realize what point actually is. It's this curve. This is the definition of a point. The point is the proton, and that point has a radius inside which nothing can get if it's an electron. The electron cannot get in. Why then is it accelerating toward the proton? This curve answers that question. You have to do something that no physicist or mathematician has ever done before, but you don't need to worry about stretching or losing your mind. All you have to do is use pure geometry. And that alone gives the answer. And it's now mathematically substantiated as well. And that is the substance of my discovery, which is now going out to consensual science for review. But I actually don't care too much about that. I'm only interested in expressing this to you. So go to anagalactic.space and start making comments on the documents you find there. You can now make comments to me. You don't need email, and you don't need to leave comments in the videos if you find that to be too much, that you don't fucking want to do that. Well, you shouldn't have to. If you want to talk to me, talk to me. Now you can. The site is protected. It's an HTTPS address. It's not to say that no one else can see your comments. Anybody can go to anagalactic.space and look at the documents the same as you can and see your comments on my documents. I can answer you too. So it's a chat room. And you are invited. Anagalactic extends this invitation to anybody who's, well, rational. All right, so that's the end of our presentation today. I hope you enjoyed that, but to actually give you the solution, so you have a takeaway here. This force curve describes, first of all, as the electron comes in, and I'm going to do this down here, right? So let's start at the correct end. All right, so here we are. This is actually up here on the horizontal line. Remember, the electron is always on that horizontal line. The magenta line that now we're going to say is in parallel, that you're seeing two things at once. On the horizontal line, as the electron is approaching the proton, I'm sorry, I'm left-right dyslexic. That's actually been shown in experiments that I've conducted. I should be going this way, but it's actually, I can't. I have to focus entirely on making it go the right way because of my left-right dyslexia. Because I'm not seeing a mirror image here. I'm seeing a cross image. And I just can't do that. It's like it has something to do with me not being able to make decisions unless there's a woman to assist me. I didn't say that right. Anyway, you don't need to hear that again. So, okay, let's see if I can get this out of the way. Oh, fuck. So, here's the distance that the fucking electron has to go. Oh, God. I'm sorry, but I swear when I'm nervous. Okay, so the electron is going to go like this, okay, right? And it's accelerating into the proton, okay? That's what it's doing. But I'm not going to try to point anymore. I'm just going to hope that you can just follow along with me as I just tell you. So here comes the electron, and now it's reached that arrow that's pointing in the opposite direction where the electron came from. So it's coming in on the horizontal line. And it has a velocity, and it's accelerating. So the purple line, I knew I would do that because magenta is not ever my first choice of words. It sounds like something, oh, never mind. So that's what it's saying. What it's saying as the electron is like in the movies when they're when the film crew is riding along beside the stagecoach so they can film what's happening on the stagecoach. Well, that's filmed from a moving vehicle. So think of this purple line as being the film crew, who are going to experience a miserable, you'll see. So now they're riding, and here they go, and they reach where 3 femtometers, 3 FM, and now the film crew, apparently their driver is drunk and veers off to the left, and they're like, no. What that means is, what that magically means is that this film crew is still keeping up. They're actually keeping up. So obviously, the film crew, though, is not going to be able to keep up forever because obviously the electron, or the stagecoach, is going to keep going on that straight line but what's happening to its velocity? its velocity is still changing, but is it still accelerating according to the force of attraction? Yeah, it sure is. You know, it's just totally stupid. Okay, so anyway. It's pot. Watch your kids. Make sure they get some. Oh. God said it's okay, so you're safe. No, I don't know if it's safe. You can't hold me liable for that. I shouldn't. Okay. So it starts accelerating. That dip where it's taking a dive, that means that electron is now humming. It's just going right toward that proton, and the proton. Oh my God, well, it doesn't know because it's like the speed of light. Can't tell. Probably can't see it coming. But if they could, boy, if they in the center of that proton, boy, they'd be scared, because here comes that electron. If they can only slow down time to see it happening, it's accelerating to crash. And so that purple line, is it taking the dip down there? Oh, shit. Is it taking the dip down? Is it taking, oh, shit. Oh, God, there we go. It's taking the dip down right there. See, it reaches the bottom at about 0.8 femtometers, believe it or not. Although that shows at about 0.7. Well, where it's going to come to rest in its electronic shell is at about 0.8. Which is about... oh, no. It's about right there. I'm sure you can see. That says, oh, shit. That says 0.5 and that says 3, okay? So it's accelerating like hell after 3.4, 3 femtometers. It's just screaming and just going faster and faster. But then at the bottom, which is about 0.7 femtometers, all of a sudden, you know, it just is going that fast. It's going maximum velocity down there at the bottom of that curve. It's just screaming, baby. Just going faster and faster than, now it's not going faster and faster. That's called a stabilization of acceleration. Only this just keeps changing. Now it's decelerating. So it's still going fast, like at we'll go 0.5, 4, 3, 2, 1, crash, okay? All right, it's at 5. This is 5. 5. It's 5 half femtos from collision, okay? All right. I told you we're filming this. We're the film crew now, okay? This is what happened to us. We accelerated. We're fucked up. We're out of control. Our driver's passed out. He's got his foot on the pedal, and we're just accelerating out of control. And then starts slowing down. So that's as the purple line is rising. That's a decrease in attraction, right? Well, when it crosses the median line, now it's being repelled. Now, it still has forward velocity, you can see, because it still curves a little bit to the left. So that electron is still going forward in space. But it can't go any farther than that vertical line. So what happens to it? Well, it's being repelled. Well, when it finally gets up to infinity, infinity? Oh, yeah. That line goes to infinity. Well, that's actually contrary to the principles of nature herself. That thing can't decelerate forever. So what is actually happening? You see, this is the mistake. It's so easy to make. the electron is not on the purple line. The electron never deviates off of the horizontal line. So what is actually happening? Okay, we're at 0.5 femtometers and at maximum acceleration. Okay? At 0.4 femtometers, we're not going as fast. Right? Because there's less attraction, so that less attraction means deceleration. So we're coming to a screeching halt. That line going straight up means the electron on the horizontal line is coming to a screeching halt. Where does it stop? Okay, at 0... oh God, I measured this wrong. That's 0. Oh shit. Well, okay. Well, it doesn't matter. I'm sure you corrected it in your mind. I should have been saying 0.7 countdown to 0.5. So I'll edit this out. No, you know what? No, this is a good lesson for... Oh, fuck, it's 45 minutes. Okay, well, I hope I gave you the secret of the universe, because you're looking at it, darling, and we're going to talk about it. Don't worry. I'm going to make sure that you get this. If that's what you want to do. Oh, this is easy to understand. That's why I'm so pixelated. This simplifies everything. Okay, so let's close off, and I'm just going to publish this the way it is, but in low resolution, so it'll go out faster. All right, then. Oh, shit. Oh, God, okay. So here's the electron, and it's coming in, and now it's accelerating, right? And now it slows down. And now it just doesn't know what to do, right? That's right. It doesn't know what to do. So what it does is, it gets pushed back, right, until it reaches the attraction-repulsion, which is on the median line. So that's where it stops. It stops on the median line, because that's the balance between repulsion and attraction. And it never gets any closer to that proton than 0.5 femtometers away. One potentially confusing aspect of that distance of 1/2 of a femtometer, that's the radius from the surface of the proton to the orbit of the electron. The spherical shell orbit of the electron is 1/2 of a femtometer off the spheric surface of the proton. But that doesn't measure the distance to the center. That measures the distance to the center. So there are two centers. That's the quantum paradox. Restated in a way that's never been stated. That leads directly to the solution. And I'll show that to you in the next presentation, I promise. But when I say next, any one of the next. Go to anagalactic.space. Let me know what you like in the comments to the U2 PDF document that you can instantly download or just read it right in there and just leave comments. But you can also download it. And we'll have more there in the upcoming days. The site is being built out now by... I'm the sole developer and designer and computer, as they used to call human beings, among whom was Henrietta Leavitt, the winner, the only woman to ever win the Nobel Prize in both physics and astronomy. Oh, I forgot. She died of cancer. Keep looking up. Stay tuned. We'll have more. I hope you enjoyed that. That was a follow-up to our U2. And I am currently publishing U3. I strongly recommend that you watch that. And then we'll have something at anagalactic.space to cover that. And that's a long time. Thank you for your patience. Thank you for tuning in. This is Anagalactic. We'll be right back. Keep looking up.